Check one. Check one. Tube. Right. Hurry. Right. Shh. Right. Shh, 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 shh. Now, last week we distributed the tube. Those who don't have the tube, raise the hand. Raise the hand and they'll come and give. Online people, I hope you all have the tube. Online people. For the online people, I'll keep the group open. If you don't post a question there, tell me. For online people, may tell to the group, WhatsApp group is open. Is everything clear? Hurry. Clear. Hurry. Right. Shh. Today, a special class for the online, of course, it's a free stream. Special class from 8:30 to 12:30. Kind of a seminar, right? Kind of a seminar. Structure of matter. Structure of matter. That is because I told you in other places I do grade 10 for 2.5 hours. Y'all, until now, we did only for 2 hours or half an hour, whatever the half an hours that came as a remaining part. Today, we are going to cover everything. Ekai 8:30 to 12:30, a long hour class. But next week onwards, what is our usual time going to be, Lamai? 10, 10 a.m. to 12:30 p.m. 12:30 p.m. That is our usual grade 10 time from May onwards. Only today we are doing a long hour class. Normal time is 10 a.m. to 12:30 p.m. That's the normal time. We'll start the work then. Start the work. Structure of matter. Structure of matter. Structure of matter. There you go. This is our unit number 3. Unit number 3. Hurry, listen. This is the first chemistry section that you learn in grade 10. That means in your O-level journey, the first chemistry section that you are going to learn is structure of matter. Only very few chemistry sections are there. Everything is interconnected. Physics and bio are not like that. Chemistry, unless you understand this section properly, it will be hard for you to go for the next chemistry section. Next chemistry section is going to be quantification of elements and compounds. To understand next section in grade 11, you learn about mixtures, calculations in mixture. That become hard. In the everything in this chemistry is interconnected. So this is the base there. From the base until the end, learn it properly, put it to the mind. Don't go home with any doubts, because you are going home with doubt. Your next lesson is going to be hard. That's the meaning. Going home with doubt, that doesn't mean okay, only this lesson you have doubt. Doubt in this lesson means your next chemistry lesson is guaranteed going to be hard. So this chemistry lesson from on onwards itself, catch up and go. Okay, online people the same. Don't keep any doubts. You can post the doubts to the group. Group is open, or ask in the chat box. Clear out the doubts. Clear out the doubts. Okay. Right. Structure of matter. Under structure of matter, what we learn about, we mainly learn about this matter. We mainly learn about this matter. My very first question, a grade 6 question. What is a matter? That's the grade 6 second lesson first question. What is a matter? Grade 6 question. Grade 10. What is a matter? Anybody? Has a mass. Okay. Occupy space. Two things you need to tell when someone asks you what is a matter. What are the two things? One, something that has a mass, as well as occupy space. Something that has a mass and occupy space is matter. Something that doesn't have mass, doesn't occupy space is energy. Keep that in mind. Huh? Has mass, occupy space, matter. No mass, doesn't occupy space, energy. So turn your tube, first page. What is matter? Under that, write down. Under that, write down. Things that has a mass, has a mass and occupy space. Things has a mass and occupy space. Occupy space, full stop. Now, online people, in case if you don't have the tube, at least have the PDF version of it. I posted to the group. Have the PDF version of it. Writing part, write it in a writing book. So later you can take a printout, copy it to the printout. Okay. Come to this board. Now, Lamai, when you take this matter, matter is mainly divided into two. Matter, there you go, mainly divided into two. Matter mainly divided into two. What are those two? One, pure substance. This is a grade 9 work. Pure substance. On the other hand, you call it, but the exact name is mixtures. Pure substance and mixtures. So two types of matter, pure substance and mixture. This pure substance again divided into two. Pure substance again divided into two. What are those two? One, elements and compound. Elements and compound. Elements, on the other hand, compound. Same thing is there in grade 9. Elements and compound. Can you all tell me some examples for elements? What are the examples for elements? Now, sodium. Sodium is an element. Symbol for sodium is Na. Sulfur. Sulfur is an element. Symbol for sulfur is S. Hydrogen. Hydrogen is an element. H2 gas. Element. Oxygen, O2 gas, element. Nitrogen, N2 gas, element. Then what are elements? If a substance is made of same type of atom, it's element. Sodium only made of sodium atom. Sulfur only made of sulfur atom. Hydrogen, H2 is there, both are what? Hydrogen atom. Same type of atom. Oxygen, O2 is there, but both are what? Oxygen atom. Same type of atoms now. Then different types of atoms now. Compounds. What are the examples for compounds? See, sodium joining with chlorine, sodium chloride. Different types of atoms are joined together. HCl, hydrogen joined with chlorine, compound. Calcium carbonate, three types of atoms are there. Calcium, carbon, oxygen. Glucose, what's the formula for glucose? Glucose, you all know. C6, H12, O6. All these are compounds. Okay. On the other hand, mixtures. Mixtures are also divided into two. That is also there in grade 9 Lamine. What are those two? One, homogeneous mixture. Homogeneous mixture. And heterogeneous mixture. Homogeneous mixture and heterogeneous mixture. Example for homogeneous mixture. Salt solution. What do you mean by salt solution? Salt dissolved in water. Salt solution. Sugar solution. What do you mean by sugar solution? Sugar dissolved in water. Glucose solution. Glucose dissolved in water. All of them are homogeneous. Heterogeneous. Salt and pepper together. Salt and pepper. Now, when you go to a hotel, they'll use salt and pepper to you. Salt and pepper. It's a mixture. Heterogeneous mixture. Sugar and sand together. Very uncommon combination. Sugar and sand together. Heterogeneous mixture. Okay. I know now most of y'all, so many things are running in your mind. Hari sir, matter is clear. Pure substance, mixture, element, compound, homogeneous mixture, heterogeneous mixture, not clear, no? Don't worry. Our O-level syllabus is this. You'll have to study about elements, you'll have to study about compounds, how to quantify them, how to represent them in moles, Avogadro constant, how these compounds are formed, what are the bonds they have, how to represent the bond, Lewis structures of them, how mixtures are formed, what are solutions, how to find the solubility of them when you increase the temperature, what happens with them, how to separate the components in a mixture, how to calculate the concentration, how to calculate the mass fraction, how to calculate volume fraction, how to calculate mole fraction, how to calculate parts per minute. Our syllabus. That's our chemistry syllabus. Additionally, one more section will come, electrochemistry. That's a separate section. After all these things are done, electrochemistry. That's it, O-level chemistry. So throughout this O-level journey, you'll be studying about all these things slowly. Okay. We'll first write it. In your tute, a big box is given. In that box, I want you all to write this. Nicely write it. Use some color pens because this is our syllabus actually. Online people, any doubts? Use the group. Online people? No, no. Hurry. Online people, once done, tell me done, in the chat box or in the WhatsApp group. Okay. Right. Shh. Now, Lamai, we know matter. Matter has a mass, occupies space. So when scientists started thinking about matter, they wanted to find out what is there inside matter, with what matter is made from. Different scientists told many different things about matter. When they don't know something, they tell all the lies in the world. There was a fellow called Aristotle. That fellow told nothing is there inside matter. He can't prove because this was in very olden days. No any experiments were done just by imaginations. Those people are not called as scientists, they are called as philosophers. They just represent some ideas, not experimentally proven. So that fellow told, which fellow? Aristotle. He is telling nothing is there inside matter. At that same time, another person was there, Democritus, just like your friend. When you tell something, your friend tells the exact opposite of it. No, Democritus told me, Aristotle, listen, will you? You are telling lies. Matter is made of small particles. Who is telling? Democritus. Aristotle telling nothing is there inside matter. Democritus is telling matter is made of small particles. What a debate between those two people. A very famous debate was there. You can search about that debate. Debate between Aristotle and Democritus. Aristotle won the debate. That means he he not confirm, he didn't prove it also. His idea became okay, correct. What was his idea? Matter is made of nothing. Nothing is there inside matter. People started believing it for many years. Come to this board. For many years, people started believing it. Recently, about 500, 600 years ago, there's a person called John Dalton. Watton Dalton. What Dalton? John Dalton. Now, what is John Dalton telling us? He is telling what Democritus told is correct. Matter is made out of tiny particles. He is not only telling that, he is experimentally proving it. He experimentally proved that matter is made out of tiny particles, very tiny particles. Matter is made out of tiny particles. Additionally, he told these particles are indivisible. Indivisible means you can't divide them further. Very tiny, you can't divide them. So John Dalton told matter is made out of very tiny indivisible particles. The building unit of matter is those small particles. Once when he find it, he need to give a name to that. No, what are those tiny particles going to be? Now let's take John Dalton is a Sri Lankan Sinhala person. He's born in Sri Lanka. He's from Candia, Katukastata, that area. John Dalton Silva. So now Silva, let's take. Mr. Silva has found about this tiny particle. So what the name he will give? Very tiny, no? Something in Sinhala related to tiny. Chuti. Matter is made out of chuti. Chuti cannot be divided. This bottle is made out of chuti. Chutis are there. Many chutis are there inside this bottle. That's what he will give. In case if John Dalton is a Tamil guy. Let's take he's from Jaffna. He's a Tamil person. Right? John Dalton Sundar. The name. Right? What he will tell now in Tamil, he will tell something. No, kutti. Matter is made out of kutti. Kutti is indivisible. All the things in this world are made of kuttis. Many kuttis are there everywhere. Lot of kuttis are there. He will name. But fortunately, unfortunately, he was a Greek person. In Greek, are kutti, chuti. In Greek, that means atomos. What does that mean? Atomos. So in Greek, he is telling it is kutti. It is chuti. That's the meaning there. Right? He is telling it is atomos. Later, it was redesigned as atom. So these tiny indivisible particles are called as, what do you mean by atom? Kutti. Chuti. Hima you can write in the exam. Atom means tiny indivisible particles. What do you mean by atom? Tiny indivisible particle. So everything as a nutshell, John Dalton is telling that matter is made out of tiny indivisible particles. That's the building unit of matter. That is called as what? Okay. Understood up to there? But Dalton is lying. He's lying. Culprit. What is he lying? Now he is telling matter is made out of tiny particle. That is correct. Indivisible particle. What do you mean by indivisible? Cannot be divided further. That's a lie. Later, after John Dalton, they discovered that inside atom, there are some particles. Inside atom particles are there subatomic particles. So inside atom there are particles, they called it subatomic particle. Actually there are 3 subatomic particles. How many subatomic particles are there? 3 subatomic particles. So atom is actually made out of 3 subatomic particles. Then you all tell me, is atom really indivisible? No, it can be divided further. When you divide it, you can see those subatomic particles. What are those subatomic particles? I will go in the order of discovery. First, there was a subatomic particle called electron discovered. Electron. Next, proton discovered. Next, neutron discovered. Then again tell me, what are the 3 subatomic particles? Electron, proton, neutron. Again tell me, what are the 3 subatomic particles? Proton, neutron. They have some charges also, Lamai. Electron has a negative charge. What's the charge electrons have? Negative charge. Protons have a positive charge. What's the charge protons have? Positive charge. Neutrons are neutral. That means they have 0 charge. Again, what are the 3 subatomic particles? Proton, neutron. Electron, what's the charge? Negative charge. Proton, what's the charge? Positive charge. Neutron, what's the charge? 0 charge. They have some masses also. Mass of a proton is 1 atomic mass unit. Amunevi, atomic mass unit. One atomic mass unit. Very tiny, no? Protons are patta tiny, no? You can't represent that mass in grams, no lamai. Or a tiny. If you try to represent the mass in grams, it will be a very small value. Therefore, they have developed a separate unit. That unit is called as AMU, atomic mass unit. So proton's mass is one atomic mass unit. Neutron's mass is also one atomic mass unit. But actually speaking, neutrons are little bit heavier than proton. Even though we consider both their masses are same, actually speaking, neutron is little bit more heavier than proton. Okay, but almost they are equal in masses. So this is one atomic mass unit. Neutrons are also one atomic mass. Then what about electron? Electron is very, 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 very tiny. That means you take a proton. This is a proton, eh? You cut it. You take a proton and you're cutting. Think of doing that work. The worst job in the world. Taking a proton, cutting it. Cutting it into how many pieces? 1840 pieces. The most worst job in the world. Cutting a proton into 1840 pieces. Cutting, that is actually chopping into 1840 pieces. You cut it into 1840 pieces. Take one piece out of that. One piece out. Now that's the proton cut into 1840 pieces. Take one piece. You measure the mass. That's the mass of a electron. Then think of the mass of electron. Proton is itself chuti. That chuti proton, you cut it into 1840 pieces. From that you take one piece out. Will it have any mass? Almost a negligible mass. Almost a zero mass. But if I mathematically represent it, 1 over 1840 of the mass of proton is the mass of electron. Mathematically think 1 over 1840. 1840 from that 1 of the mass of proton is the mass of electron. Okay, clear. Finally, who discovered them? Can we take the boat little bit to that side? Who discovered them? Electrons were discovered by Sun. What Sun? Thomson. What Thomson? J. Thomson. Protons were discovered by Ford. What Ford? Rutherford. What Rutherford? Ernest Rutherford. Neutrons were discovered by Wick. What Wick? Chadwick. What Chadwick? James Chadwick. So they were the people who discovered. Then electron, what's the charge? Negative charge. Proton, what's the charge? Positive charge. Neutron, what's the charge? Zero charge. Masses. Proton, one atomic mass unit. Neutron, one atomic mass unit. Electron, 1 over 1840. The mass of proton. Discovered by electron, J. Thomson. Proton, Ernest Rutherford. Neutron, James Chadwick. Okay. Now take your tube under that box. Building unit of matter is atom. Atoms were discovered by John Dalton. Underline or highlight his name, John Dalton. Atom means cannot be divided further. But however, Later, it was discovered that atoms were made of 3 subatomic particles. Tell me louder, what are the 3 subatomic particles? Proton, neutron. Can you all write it there? Electron, proton, neutron. No need to write all these things, only write their names. Electron, proton, neutron. Next, electrons are negatively charged. Protons are positively charged. Neutrons have no charge, 0. Protons have a mass of 1 atomic mass unit. Neutrons have a mass of 1 atomic mass unit. Mass of an electron is 1 over 1840 of the mass of proton. Negligible. Okay. Don't worry now. These things, we will be separately writing them on a separate table. No need to rush in right now. I will separately give it on a separate table. So don't write it now. Now going to the structure of atom. Come to this board. Structure of atom. Structure of atom. Atomic structure. Structure of atom. Listen, all sit properly. All sit properly. Structure of atom. Structure of atom. All right. Now, Lamai, once when these subatomic particles got discovered, our scientists wanted to find out what is the structure of atom. How atom is going to be. Is it going to be like a football? Is it going to be like a tennis ball? Is it going to be like a strawberry? Is it going to be like a pudding? Is it like jelly? Is it like plum pudding? So many doubts were there. What is the real shape? What is the real structure? How are the electrons located? How are the protons located? How are the neutrons located in an atom? Big doubt now. Many scientists started to do researches. They wanted to find out how this atom is arranged. J.J. Thomson is there. No? J.J. Thomson. Pandit. A. Just after the electrons and protons were discovered, just after electrons and protons were discovered, just after electrons and protons were discovered, even before the discovery of neutron, Pandit fellow, he wanted to find out the structure of atom. Just using electron and proton. Now, this is not even discovered. Even before everything is discovered, he wanted to quickly find out the structure of an atom. Just with the electron and proton, he wanted to find out the structure of atom. You all tell me then, is that structure a correct structure? Nah. Hey, we'll have to study that structure. What's the structure going to be? Listen, will you? Come to this board. See, protons are there. No? Protons have a mass. 1 atomic mass unit. So you take a proton, it has a big mass. Does electrons have any mass? Look at me, I'm beautiful. Does electrons have any mass? Oh, protons have a big mass. Protons have a mass. Does electrons have any mass? No, negligible mass. So protons have a mass. Electrons do not have much mass. They're very small. Protons have big mass. Electrons have very small mass. So what did J.J. Thomson told? Atom is made of a cloud of proton. Atom is made of cloud of proton because proton only has a mass. It provides the mass for this atom. atom is made of cloud of proton. A cloud of proton makes the atom. Atom is made of cloud of proton. Protons are very big. Again, they have a mass. So atom is made of cloud of proton. In that cloud of proton, here and there, electrons are embedded. Electrons are embedded. Here and there, electrons are there. Here and there, electrons are there. Here and there, electrons are there. So full atom is made of proton. On that, here and there, electrons are there. While he was thinking about the structure, his wife came with a plum pudding on the hand. He looked at the plum pudding. He looked at his structure. Plum pudding, his structure. Almost same. In plum pudding, pudding is made of, flour-like thing. Here, pudding, here atom is made of proton. On that, electrons are embedded. On the pudding, plums are embedded. So, have you seen plum pudding? On the pudding, plums will be just put. So, he saw his structure, plum pudding structure, both are same. He named this as plum pudding model of atom. Correct name? No? So, he gave the name as plum pudding model. This is plum pudding model. Or plum pudding structure of atom. Okay. So basically the atom is made of cloud of proton. On that electrons are embedded. That's the structure. You all tell me, is it a correct structure? Plum pudding why? Is it a correct structure? Nanny, why? What is missing here? Neutrons are missing. So this is not a correct structure. But for some time, people believe that this is correct structure. Who discovered this? Or Panditya? J.J. Thomson. J.J. Thomson. This fellow only discovered. Okay. In your tute, atomic structure. Plum pudding model. Those who came now get the tutes. Plum pudding model. J.J. Thomson introduced that atom is a positive cloud in which negatively charged particles are embedded. Just like the plums in a pudding. So I have given both those structures there. So that structure is not at all a correct structure. So this structure people refused. After some time, people refused. Next comes Ernest Rutherford. Next comes Ernest Rutherford. Now already you know about Ernest Rutherford. Why? He only discovered proton. This fellow, after the neutrons were discovered, now he is trying to tell the model of atom. How the atom is going to make. J.J. Thomson, you keep quiet. It's not like plum pudding. Another subatomic particle is there. Neutron is also there. You take your pudding and get lost. I will tell the correct structure of atom. According to Ernest Rutherford, what is the structure of atom? Listen, most of the part in an atom is empty space. You take an atom, most of the part of the atom is empty space. A greater part of the atom is just empty. The total mass of the atom is concentrated at the center. Total mass of the atom is concentrated at the center. That center is called as nucleus. Center is called as what? Nucleus. Greater part of the atom is empty space. Total mass of the atom is concentrated at the center. That center is called as nucleus. Okay. Inside this nucleus, Two subatomic particles are there. What are the two subatomic particles inside nucleus? Proton and neutron. Proton and neutron are there inside the nucleus. Proton and neutron are there inside nucleus. Okay, again see what is Ernest Rutherford telling us? Greater part of the atom is empty space. Total mass of the atom is concentrated at the center. That center is called as nucleus. What is there inside nucleus? Proton and okay. This is now don't think now nucleus it's more a big structure. I will compare and tell this. Let's see. A big football stadium. A big football stadium. It's like atom. A football stadium is even bigger than a cricket ground. In cricket, you just need to hit maximum 6, no? 6. When it comes to football stadium, from one goal post to the other goal post, the ball should be passed. So football ground is even bigger than a cricket ground. Okay. Imagine an atom is like a football stadium, the football ground. You run to the center of that ground. Take a chickpea. What is chickpea? Kadala. Take a kadala, chickpea. Keep it at the center. Chickpea is like the nucleus. Now compare the size. Atom is the football ground. Chickpea is the nucleus. You can understand the size comparison now. So greater part of the atom is empty space. Total mass is concentrated at the center. That's a very tiny point. The tiny point is called as nucleus. Inside nucleus, you have proton and okay, clear. Then y'all tell me, what's the charge in this nucleus? Something for you to think and answer. What's the overall charge of nucleus? See, protons are positively charged. Neutrons are zero charge, no any charge. Then what will be the overall charge of nucleus? Overall charge of nucleus is okay. Now one person is missing. Who is missing? Electron is missing. Electron is something like this. I think now in a wedding or in an important function, there'll be small kids running here and there for no reason. They itself don't know why they are running. They go that side. They go this side. They themselves don't know why they are running here and there. Electrons are just like those small kids. These electrons revolve around the nucleus just like that small kids. Correct? No? Electrons do not even have a mass. No? Very tiny. That fellow keeps on going, goes around this nucleus. Keeps on revolving around the nucleus. Okay, all the electrons, they revolve around the nucleus. Nucleus is at the center. Electrons revolve around the nucleus at a very high speed. Okay, clear about it? They are revolving around the nucleus. They will have a path to travel neither. They revolve around the nucleus. They have a path to travel. That path, that road, that route is called as energy level. That path is called as what? Energy level. Another name is also there, orbital. Another name is also there, shell. But actually speaking, all these are different things. Energy level is different. Orbital is different. Shell is different. But in O-level syllabus, we consider energy level, orbital, shell, all are same. Okay. So if someone asks you, where are electrons located? What's your answer? Energy levels. Nothing orbitals or shells. because they revolve in that path. So they are located in energy levels. Understood? Up to there clear? Now tell me, electrons, what is the charge that electrons has? We already know. What's the charge electrons has? Negative charge. Electrons are negatively charged. Now think. Electrons are negatively charged. Overall charge of the nucleus is positive. Now think, huh? Electrons are negatively charged. Overall charge of the nucleus is positive. Opposite charges, they will attract. ඒ කියන්නේ this electrons are attracted to the nucleus නේද? Agree? Electrons are negatively charged. Nucleus is positively charged. Opposite charges are attracted. That means electrons are attracted to the nucleus. If electrons are attracted to the nucleus, what should happen to the electrons? Electrons should come and fall on the nucleus, isn't it? Think practically. If electrons are attracted to the nucleus, it should come and fall onto the nucleus. If electron comes and fall onto the nucleus, what will happen to the size of the atom? Size of the atom will, think practically. If electron come and fall, size of the atom will decrease. If size of the atom decreases, the size of the matter should decrease. Is it happening? This whiteboard, see whether the size is reducing? එහෙම පේනවද? No. No any issues? Is the size decreasing? Then y'all tell me, is the size of atom decreasing? Is the electrons falling on the nucleus? How? How electrons are not falling on the nucleus? Now, electrons should fall on the nucleus. Now, electrons are negatively charged. Nucleus is positively charged. Opposite charges are attracted. They should go and fall. But how come they are not falling? Now, listen, will you? I told you, electrons are revolving around the nucleus at very high speed. Electrons revolve around the nucleus at very high speed. Even though electrons are attracted, they are going at a very high speed. What? Hurry. Now this mic, it's the electron. Imagine, it's not electron. Mic is the electron. Okay. I am the nucleus. Okay. I am the nucleus. This is electron. I am nucleus. So wire, this wire, it's the attraction. If I just keep the electron, electron is attracted to me. See, it's coming and falling on me. If I give the electron, see, it's coming and falling. Hello. And falling. So when I just keep the electron, it's attracted to me, it's coming and falling. Okay. To avoid it, what I am doing now, I am going to rotate. I am going to rotate this. Now tell me, is the electron falling on me? It's attracted to me. It is not falling on. As well as, is it leaving me? No, it's not leaving me also. It's always around me, revolving around helicopter. So understood now how electrons are not falling on me? Why? Because electrons are revolving around the nucleus at very high speed. If I stop the rotation, now see, if I stop the rotation, now rotating, if I stop it, it's rotating. If I stop it, see, electrons will fall. You can see? It's rotating, I stop it. See, it's coming and falling on me. So as it is rotating only, it is going around. As it has a high speed only, it's going around. If we stop that speed, if we reduce the speed, if we try to stop it, what will happen to the electron? It will come and fall on the. Understood that point now? Clear about it? So remember, electrons are always revolving around the nucleus, but not falling on the nucleus. Why? Because they are revolving at a very high. Okay. If speed decreases, they will come closer. Can be. So those are the important points. Again, tell me, atom. Greater part of the atom is a empty space. Total mass of the atom is concentrated at the center. That center is called as nucleus. Correct, Nolam? I see. 3 subatomic particles are there: proton, neutron, electron. What is the mass of proton? 1 atomic mass unit. What's the mass of neutron? 1 atomic mass unit. You tell me, does electrons have any considerable mass? Almost zero mass. That means, can you see? Total mass of atom is at the center. Massless particles are only revolving around the nucleus. That's why we tell total mass is concentrated at the center. And it is revolving at a high speed. When something that doesn't have mass revolve at a high speed, can you see something there? No. That's why we tell it's empty space. Just like the small kids in the wedding, when they run at a very high speed, sometimes we don't see. Waiter will come and knock on that fellow, all the drink will fall on that fellow. Can't see, no? High speed. Okay. Hurry. When you look at this, what comes into your mind? It's just like the solar system need. Sun is at the center. Planets are revolved. Now don't think only one electron is there. Several electrons will be there. Several electrons are there. They revolve around the nucleus. So can you see this is just like our solar system? Sun at center. Planets are revolving. As this is like the solar system, Ernest Rutherford named this model as planetary model. What model? Planetary model. Arare plum pudding, jelly pudding, even. This is planetary model. Take the tube. Planetary model. Planetary model of atom was introduced by Ernest Rutherford. Underline or highlight his name. Greater part of an atom is empty space. Protons and neutrons are concentrated in a very tiny area called nucleus. At the center of an atom. Underline or highlight the word nucleus. Which means total mass of the atom is concentrated at the nucleus. And it is positively charged. Nucleus was first discovered by whom? Ernest Rutherford. Makes sense, no? That fellow was only making this model, then that fellow only found out nucleus. Electrons revolve around the nucleus. The path that the electrons revolve are called as energy levels, orbitals, or shells. Underline or highlight those names. Very important, huh? Energy level, orbital, shell. Question. Why doesn't electron fall on the positively charged nucleus? Why doesn't the electron fall on the nucleus? Because electrons are revolving at very high, right there. Because electrons revolve Because electrons revolve at a very high speed. At a very high speed. Around nucleus. Around nucleus. Right. Next. Now listen, eh? Now listen. Shh. Come to this board, will you? Hurry. Shh. In a neutral atom. Shh. In a neutral atom. What is a neutral atom? Neutral කියන්නේ what ළමයි? Zero charge. Neutral atom කියන්නේ total charge of the atom is zero. Neutral. Zero. In a neutral atom, ඒ කියන්නේ total charge is zero. Y'all tell me, for the total charge to be zero, if there are 5 positively charged subatomic particles, how many negatively charged subatomic particles should be there? Mathematically think it. Overall charge is 0. 5 plus is there. How many minus should be there? 5 minus should be there. A කියන්නේ, if there are 5 protons, how many electrons should be there? Louder, louder. 5 electrons. Then only the overall charge can become 0. That means in a neutral atom, number of protons and number of electrons are going to be. So if there are 10 proton, how many electrons? 10 electrons. If there are 20 proton, how many electrons? 20 electrons. So in a neutral atom, number of protons and number of electrons are equal. Okay. That point is also given. In a neutral atom, number of electrons and number of protons are equal. And the structure is given. Come to this board. In that structure, lamai, nucleus is not marked. Only proton is marked. Look at that structure. Don't look at my face. Look at that structure given there. Center nucleus is not written there. Can you write it? Arrow is given, only proton is written. Write there nucleus, proton plus neutron. May take a right there in the structure given. Mention it as nucleus, proton plus neutron. Right, come to this board. Now everything we are going to summarize. Hurry. Subatomic particle. Tell me the 3 subatomic particles. Now, shatta you should tell louder. Eh? Tell me the 3 subatomic particles. Electron, proton, perfect. Electron, proton, neutron. Charges. Electrons have negative charge. Proton, positive charge. Neutron, zero charge, neutral. Masses, we'll start from proton. Proton, 1 atomic mass unit. Neutron, 1 atomic mass unit. Electron, 1 over 1840 of the mass of proton. Location. Where are electrons located? Electron, energy level. Electrons are in energy level. Tell me another name for energy level. Orbital. Another name. Proton, nucleus. Neutron, discovered by. Electrons, sun. Thomson. Pandita Thomson. J. Thomson, sorry. Proton, Ernest Rutherford. Neutron, James Chadwick. The table is given. I want you all to fill it. Try to fill it without looking. Online people, any doubts? Only electrons are there in energy level. Yes, only electrons are present in energy levels. Is there only one electron? And I'll tell how many electrons will be there. But remember, only electrons are there in energy level. So how can the nucleus charge be decreased if the two charges are attracting? Not nucleus size, atom size. When electrons are going for, when electrons fall on the nucleus, guaranteed atom size will only decrease. What's the online schedule for grade 10? Grade 10 is from 10 to 12:30. Then if there are any doubts, you can write a chittens in front and back rows, Hurry, ne? Right, come to this board. Right. Shh. One more point to be added. One more point to be added. Listen, ne? Shh. One more point to be added. Now, according to the model that Ernest Rutherford represented. Listen. Shh. According to the model that Ernest Rutherford represented, Ernest Rutherford is just telling electrons revolve around the nucleus in energy level. That's it he is telling. But later, there was a scientist called Niels Bohr. Niels Bohr. Very famous scientist. Niels Bohr. What is Niels Bohr telling us? What is Niels Bohr telling us? Yes, electrons revolve around the nucleus in energy level. That is the path that they revolve. But those paths are definite paths. What kind of paths? Definite paths. There are definite paths for the electrons to travel. They can't travel in whatever the path that they want. There are exactly specified definite paths for the electrons to travel. Who is telling this? Niels Bohr. I know, still you can't think of this. What is this definite path and normal path? I'll tell an example. Let's take you go to a jungle. Jungle. Is there a proper path for you to walk in a jungle? You can walk in any path that you want as long as you don't get lost. There are no roads there. There are no road signs there. Nothing is there. You can select the path and go. Ernest Rutherford's model is just like that. Electrons can travel. But what is Niels Bohr telling? No, it's not like a jungle path. It's like the normal main roads in our cities. Main roads in the city. It has a definite route. No, you can't travel in whatever the way you want. No, it has a definite. So electrons can't travel in whatever the route that they want. They have a definite path to. Okay, clear about it. So accordingly, the final structure of atom is something like this lamine. Center is the nucleus. Around this nucleus, electrons are revolving in their definite path. Now don't think that electrons are revolving and the atom is like a flat paper. Atom is 3D. Around it you have paths. Now let's take this is the nucleus. This is the nucleus. Around this, electrons are revolving like this. That is one path. Electrons are revolving like this. Another path. Electrons are revolving like this. Another path. Like this. Another path. So three-dimensional you need to think. That's why when you go to internet and type atom, or to type chemistry or something, you get pictures like this is the real structure of atom. No, nucleus can't revolve. Nucleus is at the center. Okay. Clear about it? Now, Niels Bohr is telling electrons revolve in definite paths. No? That means they have definite energy levels. No? Those definite paths, he gave some names to them. He gave numbers and names. Starting from the energy level closer to the nucleus. Starting from the energy level closer to the nucleus, he gave names and names. What are those names? First energy level is K energy level. Second energy level is L energy level. Third energy level is M energy level. Fourth energy level is N. You can keep on going. But mainly only 4 energy levels we study in our syllabus. So there are, we can tell there are 4 main energy levels: K, L, M, N. K is closer to the nucleus. After that L, after that M, after that N. So if I draw and show, nucleus is at the center, closer to the nucleus. What is this energy level? K. Second, L. Third, M. Fourth, N. That's how the energy levels are. In that electrons are revolving. Understood that point? Clear about it? Take it out again. Niels Bohr, who further elaborated Rutherford's model, stated that the electrons move in definite paths. Underline or highlight that word, definite paths. Definite paths around the positively charged nucleus. The shells in which the electrons revolve around the nucleus are assigned either numbers or letters. 1, 2, 3, 4 numbers, K, L, M, N letters respectively, starting from the nearest to the nucleus. The shells are also known as energy. Okay. Now a very, very important point. Very, very important point. Listen, eh? Listen very, very carefully. All sit properly. All sit properly. Drop your pens. Right. Listen, eh? When you go away from the nucleus, when you go away from the nucleus, what is going to happen? Listen very carefully. Lamai, there are energy levels, K, L, M, N energy levels are there. No? Each energy level has a energy value. First energy level has an energy value. Second energy level has an energy value. Third energy level has an energy value. Fourth energy level has an energy value. Each energy level has a energy. I'll draw it and show. Now what I'm going to do is, I'm going to draw half of the atom and show. Mehima. Only half of the atom I'm going to draw. Bigger diagram of half of the atom. Listen very carefully. Eh? Center is there you go nucleus. First energy level. Second energy level. Third energy level. Fourth energy level. Energy levels are drawn. First energy level is called as what energy level? K. Second energy level is L. Third, M. Fourth, N. Each energy level has a energy value. First energy level, let's take, just imagine energy is about 20 joules. Energy is measured in joules. Just imagine 20 joules. Second energy level will be about 100 joules. Third energy level will be about 2000 joules. Fourth energy level will be about 50,000 joules. Now, looking at these values, you all tell me. 20, 100, 2000, 50,000. What is happening to the energy in the energy levels when you move away from the nucleus? Increasing or decreasing? Increasing. Can you see that? When you move away from the nucleus, energy in the energy levels are increasing. Don't think they have 20 joule, 100 joule. Big values are there. I will write them using symbols. I will write here the energy is E1. Here the energy is E2. Here the energy is E3. Here the energy is E4. So when you move away from the nucleus, what is happening? Energies are increasing. E4 is the greatest. E4 greater than E3 greater than E2 greater than E1. 20 joules, 200 joules, 100 joules, 2000 joules, 50,000 joules. So remember, when you move away from the nucleus, energy in the energy levels increase. Again, one more time. When you move away from the nucleus, energy in energy levels increase. Again, tell me, when you move away from the nucleus, energy in energy level increase. Next point. What can you tell about the gaps between energy levels? When you move away from nucleus, what can you tell about the gaps between energy levels? Gaps are decreasing. Can you see that? See, first gap is this much big. Second gap is little smaller. Third gap is even more. So gaps between the energy levels are two important parts. When you move away from the nucleus, energy in energy levels increase. Gaps between the energy levels decrease. Again, one more time, tell me louder. When you move away from the nucleus, energy in energy levels increase. Gaps between the energy levels decrease. Again, one more time. When you move away from the nucleus, energy in energy levels increase. Gaps between the energy levels decrease. Clear? Understood that point? So in your tute, that point is given. Each energy level has a specific energy. When moving away from the nucleus, this energy increases. And the difference between the energy level, difference is the gap. Under that difference in a pencil, write down gap. And the difference is the gap. Difference is the gap. The difference between the energy levels decrease. A big box is given. I want you all to write this. And write E4 greater than E3 greater than E2 greater than E1. Think and draw. Use a pencil. Now you all know the things. Now gap should decrease and go. Evatica, think and draw. Don't just draw, think and draw. Can we zoom it a little bit? Now decouple a little bit more. Think and draw. Gaps should decrease. Hurry. Yeah, right. Come to this board. Hurry. Right. Shh. All sit properly again. Sit properly. Drop your pens. Shh. All boys. Electrons revolve in definite paths. Those definite paths are called as energy levels, shells, or orbitals. From the closest to the nucleus, you can number them, name them, and go. 1, 2, 3, 4. What are the names given? K, L, M, N. When you go away from the nucleus, energy and energy level increase, gaps between the energy level decrease. Now going deeper. Lamai, there are 4 main energy levels. There are 4 main energy levels. Shh. What are the 4 main energy levels? K, L, M, N. Starting from the energy level closer to the nucleus, K, L, M, N. Those are the energy levels. Now I told you these energy levels are paths. They are like roads. In a road, there is a maximum number of vehicles that can travel. No? In a road, there is maximum number of vehicles that can travel. Now, if you take this DS Senanayak road, in this thing, can about 5-6 containers travel together? Nah, then Faraday should break and go. So, that's maximum number of vehicles that can travel in a certain road. This KLMN are also just like roads. They also have maximum number of electrons that can travel. Containers doesn't travel there. Electrons travel. There is maximum number of electrons that travel there. Maximum number of electrons. Maximum number of electrons that can travel. In K main energy levels, maximum number of electrons that can travel is 2 electrons. Only 2 electrons can travel. In L main energy level, maximum number of electrons that can travel is 8 electrons. M main energy level, 18 electrons. N main energy level, 32. So K maximum, this maximum, maximum 2 electrons. L maximum 8 electrons. M maximum 18. N maximum. Now which one memorize again? K main energy level maximum number of electron. L main energy level maximum number of electron 8. M main energy level maximum number of electron 18. N main energy level maximum number of electron This third main energy level, M main energy level, has a problem. What's the problem? Even though it can occupy 18 electrons, actually speaking, there are two sub-energy levels in there. For sub-energy level, maximum only 8 electrons can travel. Second, remaining 10 can travel. But actually speaking, this 10 electron sub-energy level cannot be used. Electrons cannot be filled into this sub-energy level. Only to this sub-energy level, electrons can be filled. Even though 18 electrons can travel in M main energy level, actually how many can travel? Only 8. Remaining 10 can't. Only 8 can travel. All the 18 can't. Got the point there? Clear about it? Some roads are like that, Nolama, in Sri Lanka. Big roads are there, but both the ends are fully broken. Even though 4 containers can travel together, only a push cycle can be ridden at the center. Only center path is there. You can. Even though 18 electrons can travel here, can all the 18 can travel? Out of that 18, only 8 electrons can travel here. Remaining 10 can't travel here. What's the reason? In another 15 minutes, you will understand the reason. I'll go very deeper and explain you why all the 18 can't travel. But for now, put it to the mind, even though 18 can be occupied, only 8 can be present in M main energy level. Okay. Question. Let's say in the exam they're asking, what is the maximum number of electrons that can travel in M main energy level? What's your answer? Nah. When they ask that question like that, then your answer is 18. But there is something called electronic configuration. In another 1 hour, we will be writing that. In electronic configuration, we use only 8 electron sub-energy level. So if the question asks, how many maximum number of electrons can be occupied in M? Your answer is 18, no doubt. But when writing electronic configuration, don't take it as 18. That's my point. Again, if they ask the question as how many maximum number of electron can be occupied in M, answer is 18. In electronic configuration, don't take it as 18. Okay. Again, 4 main energy levels are there, K, L, M, N. Each one has maximum number of electrons that can be occupied. K main energy level, how many maximum number of electrons? 2. L main energy level, 8. M main energy level, 18. But actually, how many can be occupied? 8 electron. N main energy level, 30. Clear? Understood? Right. In your tube, page number 4, it's printed as only level. Write it as main energy level. And write them listen, first listen. Mn is a level, put a red color star or something. Write 18, divide it, write it in the same way. Same way I have written, write down. So many confusions will be there in your mind now. Don't worry, in another 15 minutes only, everything will be clarified. Those who came now got the tutes. Got the tute. Tutes. Right. Now I know the confusion that you all are having. So now M can occupy 18 electron. You're telling only 8 can be there. What is happening to the remaining 10? Is the road is really broken? Can't we make that road? I will buy some tar and give you. Can you make it? So many questions are running. I'll explain the reason now. Why in M main energy level, even though 18 can be put, only 8 can be put. What's the reason? I'll explain. Now, these are main energy levels. Inside main energy levels, there are sub energy levels. Come to that boot. Sub energy level. Right, I'll write it here itself. Come to this board itself. Sub energy level. Sub energy level. Maximum number of electrons. Inside main energy level, there are sub energy levels. What are the sub energy levels? S, P, D, F. Simple letters. S, P, D, F. Those are the 4 sub energy level. S, P, D, F. S, P, D, F. These sub energy levels also has maximum number of electrons. S sub energy level, maximum number of electron is only 2 electrons. P sub energy level, maximum number of electrons, 6 electrons. D sub energy level, maximum number of electrons, 10 electrons. F sub energy level, maximum number of electrons, 12 electrons. So there are maximum number of electrons in each and every sub energy level. S 2 electron, P 6 electron, D 10 electron, F 12. Okay. In your tube, sub energy level. Main energy level has sub energy level SPDF. There are maximum number of electrons that can be filled to the sub energy level. A table is given there. You all know what to do there. What to do? Write this. I want to ask you all whether it is clear because I know another 15 minutes will go for you all to understand everything clearly. After that, I'll ask whether it is clear. Write them in simple letters, SPDF. Right. So main energy levels has sub-energy levels, SPDF. Sub-energy levels has maximum number of electron, 2, 8, 10, 12. Now only everything going to get connected. Listen very carefully. Separately we learned. Now we are going to puzzle them up. Now listen, eh? Main energy levels, they have sub-energy levels inside them. एक ही आने. See, main energy level, sub-energy level, inside main energy levels, there are sub-energy level. If you take K main energy level, it has one sub-energy level S. L main energy level, two sub-energy levels are there, S, P. M main energy level, three sub-energy levels are there, S, P, D. Now we all know the pattern. N main energy level, four sub-energy levels are there, S, P, D, F. Count the number of electrons and see. See. K, you all tell me what's the maximum number of electrons? 2. L, 8 electron. M, 18 electron. N, 32 electron. Now count and see. S, how many maximum number of electron? 2. Correct? S, 2, P, 6, 2 plus 6. Altogether how much? 8. Correct? S, 2, P, 6, D, 10. 2 plus 6, 8. 8 plus 10, 18. Correct? S, 2, P, 6, D, 10, F, 12. This part is 18. 18 plus, sorry, yeah, this part is 18. 18 plus 12. 12 வந்து ஐயோ 13 இது 14. 14. 2 plus 6, 8. 8 plus 10, 18. 18 plus 4, 14. Make it 14. F 14. So altogether 32 electrons. Altogether 32 electrons. Make that 14. Huh? Now listen. Shh, shh, shh. Now listen. Shh, shh. Very important part. Listen. Shh. These electrons cannot be filled into the sub-energy level in any way you want. There is a specific filling order. I'll draw that order and show you all. You can't fill the electrons in whatever the way you want. There is a certain filling order. How it is filled? See, first, electrons are filled into S sub-energy level of K main energy level. Next, electrons are filled into S sub-energy level of L main energy level. Next, like this. Look at the pattern I am drawing it. Huh? Like that. This is the pattern. You join these patterns together. Now check and see. First, electrons are filled into S sub-energy level of K main energy level. So first, you fill 2 electrons here. After filling that, next you go to S sub-energy level of L main energy level. 2 electrons they are filled. And then you go to the remaining 6 electrons. Altogether, 8 electrons they are filled. Now see. After finishing this, next you go to S M. Two electrons filled. Follow me very carefully. S of M, A kyanne two electrons filled there. After that, you go to P of M. P of M kyanne remaining how many electrons? 6 electrons. Altogether, how many electrons filled? 8 electrons filled. After filling the 8 electrons, you go to S of N. Are you filling the D part there? D has 10 electron remaining. Are you filling the 10 electron remaining there? No. Before filling the 10 electron there, you are jumping into the next main energy level. You are going to N, filling that, and then only you are going back to the D of third energy level. Can you see that? Look at the order again. Up here order is correct. S of first energy level, S and P of second energy level, SP of third energy level. Before going to D, you go to the S of fourth energy. Only the first two energy levels of M main energy level is first field. First two field totally how many field? 8. How many left? 10. Now can you understand why I gave it like that? Road is broken. That is how it is filled. Understood it scientifically now? First the 8 electrons are filled. Before going into the remaining 10, you go to the fourth energy level and then only come back. If this is filled again, you can go back to this. Okay. After the order is correct. After this, P, D, F. After that, the order is correct. But here only that confusing order is come. S and P are filled first. Next the S of fourth energy level. Next the D of third energy level. Going up, going down, going up. Okay. Understood that point now? Clear about it? This 15 minutes of work, everything now clear? So again, tell me, what are the four main energy levels? K, L, M, N. K main energy level, how many maximum number of electrons? 2 electrons. L main energy level, how many maximum number? 8 electrons. N, M, 18, N, 32. Sub-energy level. What are the four sub-energy levels? S, P, D, F. S, 2 electron. P, 6 electron. D, 10 electron. F is 14 electrons. Because final when you count, it should become 32. Filling order. First, the S of first energy level is filled. S and P of second energy level is filled. SP of third energy level is filled. Is D filled? Before filling D, you go to the S of fourth energy level. That is why M, even though it can occupy 18 electrons, only how many electrons occupied? 8 electrons. Not all the 8. Should you know about sub-energy level? No. What you need to know? You should only know about main energy level. Only about KLMN you should know. Or SPDF Katandara you don't need. This filling order you don't need. I don't have any other ways than teaching all the correct way. No, I can't still tell lies telling road is broken, tar is not there. Then to properly teach that only, I taught all these things. This is for your chemistry knowledge, not for your exams. So during your exams, no need to go through this sub-energy level part. Only go through main energy level part. This is for your chemistry knowledge. Okay, clear? In the tube, there is a specific filling order of electrons in the sub-energy level. Under that, I want you all to draw this. Look very carefully. I have drawn how I have drawn. Use different color pens and then draw. Online people clear? Online people. Okay. Nicely think and draw, eh? So in sub-energy level, from N to M, it travels back. Isn't it a problem? No, that doesn't become a problem. That's how the electrons are filled. That's filling order. So it doesn't make any problem. When drawing, see, this comes, it goes reverse and only goes down. Goes reverse and only goes down. Goes reverse, goes down. Hima you draw. Eh? There's a small point given under that. Hence, now we can understand, even though M main energy level has 18 electron occupancy, all 18 cannot be filled at once. First, only how many electrons? 8 can be. Okay, play. Uh, take a 15 minutes break. Come back by 10:55. New students, boys' washrooms are downstairs. Girls' washroom are this side behind corridor. Clear. Sorry, right. Right. We finished up to sub energy levels, no? Come to this board. Quickly settle down. Sit properly. All sit properly. Right. So now we have a basic idea about what is an atom, how the atom is going to be, how the electrons are arranged, how the filling order is done. All those things we have a basic idea. Now going to some important quantities that you should know in relationship with atom. One, atomic number. Atomic number. Shh. Atomic number. Shush and listen. Atomic number, the symbol is capital Z. Symbol capital Z. Right. What is this atomic number? Listen. Shh. What is this atomic number? Very simple. Now my atomic number is the number of protons. Number of protons. Very simple. Atomic number is the number of protons. If there are 12 protons, then atomic number is 12. If there are 20 protons, atomic number is 20. Very simple. Then what is atomic number? Number of protons. Okay. I will ask me a question, sir. Then can't we tell it number of protons itself? Why are we calling it as atomic number? Now atomic number is number of protons now. Can't we direct it as number of protons? Why are we giving a special name atomic number? Now listen. Lamai, this number of protons in a element atom is a unique number for each and every element. That means if you take hydrogen, number of protons in hydrogen is 1. If you take helium, number of protons in helium is 2. In case hydrogen number of proton is 1, if it become 2, will it be hydrogen? It will become helium. So each and every element atom has a unique number of proton. Hydrogen number of proton 1, helium number of proton 2, lithium 3, calcium 20, sodium 11, magnesium 12, neon 18, neon 10. So number of protons in a certain element atom is a unique number for each and every element. Can that number of protons ever change? If it changes, total element should change. As it is a unique feature, you give a special name to that. What's the special name? Atomic number. When you tell atomic number, it makes a big sense there. No? Atomic number. Atoms number. It's like atoms number. Now, if you tell number of proton, it doesn't make a big sense there. Atomic number kiwama. You have a big meaning there. It's like atoms number. That number can't change. Okay, clear about it. So simple terms, what is atomic number? Number of in your tune, atomic number. Atomic number is the number of protons in an atom. It's given. Under that a box is given. In that box, write this. Hari. Next going to mass number. Mass number symbol is capital E. Capital Z for atomic number. Capital A for mass number. What is this mass number going to be? What is this mass number going to be? Mass number is equal to sum of number of proton and number of neutron. Number of proton plus number of neutron is the mass number. Very simple. Number of protons plus number of neutron is the mass number. Simply, what is this mass number means? Mass of the atom. If you take an atom, there are 3 subatomic particles. What are the 3 subatomic particles? Electron, proton. Protons has a mass. Neutrons has a mass. Y'all tell me electron. Do they have a mass? Then y'all tell me mass of an atom is decided by what 2 subatomic particles? Proton and neutron. You add those number, you get the mass number. You don't consider about electrons. Okay, clear about it? Mass number. Mass number is the number of the sum of number of protons and number of neutrons in an atom. Box is given. I want you all to write this in that box. Right, come to this board. What's the standard way of representing mass number in an atomic number in an atom? What's the standard way of representing the mass number and atomic number of an atom? Listen, what's the standard way? There's a standard way of representing the mass number and atomic number. How to represent it? Right. Let's say there is an atom. For example, I'll take atom X. Atom X can, it might be sodium atom, sulfur atom, potassium, even this is an atom. The atom. X is an atom. Shh. Atomic number of this atom is written in right side bottom. I can hear you write the atomic number. Symbol is Z. Mass number of the atom is written in right side top. I can hear you write the mass number. That means, I'll give an example. You take sodium. My sodium's atomic number is 11. Mass number is 23. Atomic number 11, mass number 23. Then how do you represent it? Atomic number 11 written right side bottom. 11 written here. Mass number 23 right side top. 23 there. That's the standard way of representing atomic number and mass number. Atomic number down, mass number on top. Okay. After you write, check whether bigger number is on top and smaller number is on bottom. Always it should be like that. IE. The atomic number is number of proton. Mass number is number of proton plus number of neutron. Then guaranteed mass number should be greater than atomic number. So bigger number should be on top, smaller number should be on. Tell me how many neutrons are here? How many neutrons? How are you telling 12? Mass number 23. We know mass number is equal to number of proton plus number of neutron. Mass number 23. Atomic number 11. Now, how many protons are there? 11. Then how many neutrons should be there? So neutrons are 12. Okay. Standard way of writing atomic number and mass number. A box is given. I want you to write both of these in that box. And then do question 1, 2, 3, 4. Do question 1, 2, 3, and 4. Write it and do question 1, 2, 3, 4. So I want the symbols. Carbon, come to this side. Carbon is C. What else is given? Sodium. Sodium is Na. Potassium. The grade 9 work on potassium K. Phosphorus P. Right, come to this board. Right. Question 1. Atomic number of carbon is 6. Mass number is 12. Represent this in standard form. Carbon. Atomic number 6. Down 6. Mass number 12. Up 12. HRI. Carbon 6, 12. Question 2. Atomic number of sodium 11. Mass number 23. Represent this in standard form. Sodium. Atomic number 11. Mass number 23. Okay. Question 3. Atomic number of potassium 19. Atomic number is given. Atomic number is given 19. Neutrons are, number of neutrons are given 20. First of all, tell me. Atomic number 19 now. How many protons are there? 19. What's the mass number then? 20 plus 19, how much? 39. What are they asking? Represent the atomic number and mass number in standard format. Potassium, atomic number 19, mass number 39. It's right. Question 4. There are 15 protons in phosphorus. Phosphorus, 15 protons are there. And 16 neutrons. Then you all first tell me, what's the mass number? Louder. Represent the atomic number and mass number in standard format. Phosphorus, atomic number 15, mass number 31. That's yours. Any doubts about atomic number, mass number? Any doubts about atomic number, mass number? Shh. Any doubts? Online people? Online people, any doubts? Any doubts about atomic number, mass number? Send to the King's Perory Zoom account. Send your doubts to King's Perory Zoom account. Clear. What's the difference between main and sub energy level? Main energy level, inside main energy level only you have sub energy levels. Right. Shh. Now going to a very, very important part. Shh. All sit properly. Voice it properly. Shh. Right. Electronic configuration. Electronic configuration. Shh. What is this electronic configuration means? Listen. We already know in a neutral atom, number of protons and number of electrons are same. These electrons can't be just filled into an atom because there is a filling order. You can't just fill. Can you fill all the electrons to K energy level? No. To K maximum, how many electrons you can fill? 2. L, how many maximum? 8. M, how many maximum? 18. But out of that, how many you can fill? 8. N, how many maximum? 32. So can you fill all the electrons just directly into the K energy level? There is a specific order in which you fill the electrons to the energy levels. You can represent that order in a written form. It will be like a nice pattern. That pattern is called as the electronic configuration. So representing the order in which electrons are filled to their energy levels from the energy level closest to the nucleus to outwards is called as electronic configuration. What? Representing the order in which electrons are filled to their energy levels. From what? From the energy level closer to the nucleus. That means first you fill to K, and then to L, and then to M, and then to N. From the energy level closest to the nucleus to outwards is called as electronic configuration. I know you can't understand the definition. I'll teach with an example. See, K main energy level, how many electrons maximum? 2. L main energy level, 8. M main energy level, 18 are there. Out of that 18, how many you can fill? 8 electrons only you can fill. N main energy level, how many? 32 electrons. Now you take an atom. For example, you take sodium atom. Sodium atom, atomic number 11. Then you all tell me how many protons are there. Now quickly you should tell. Atomic number 11, how many protons? 11 proton. It's a neutral atom. It's not having any charges. If it has a charge, it's not neutral. It's a neutral atom now. If it is a neutral atom, number of protons and number of electrons are equal. We already learned. Then how many electrons are there? Louder, louder. 11 electron. You all tell me, can you fill all those 11 electron into K main energy level? No. Then there is a pattern in which you can fill. We'll try to write down that pattern. If you take sodium, 11 electrons are there. First energy level, how many maximum electron you can fill? 2. Fill it. 2 electrons went to first energy level. Out of 11, 2 gone. How many remaining? 9. Now tell me, can you fill all those 9 into L energy level? So L, how many maximum you can fill? 8. Out of 9, 8 gone. How many remaining? That can you fill to M? Yes, you can. Can you see a pattern here? This is the electronic configuration of sodium. Representing the order in which electrons are filled into their energy level, starting from the energy level closest to the nucleus. K is closest to the nucleus. From K to outwards. Electronic configuration. Okay. One very important point. I wrote the electronic configuration for proton number or electron number. Electron number. Keep that in mind. Huh? Even though we take it from the proton number, we don't write the electronic configuration for proton number. We write it for electron number. Okay. Another one. Carbon. Atomic number 6. Then you all tell me how many protons are there. For proton number, we write the electronic configuration. No, we write for electron number. How many electrons are there? Tell me the electronic configuration. 6 electron. Can you fill all the 6 in first energy level? Then first energy level, how many maximum? 2. Comma. You should put a comma. Out of 6, 2 gone. How many remaining? 4. Then second energy level, how many? Sorry. Electronic configuration of carbon. Okay. Another one. Potassium. Atomic number of potassium is 19. Then how many protons are there? 19. How many electrons are there? Electronic configuration of potassium. Tell me, can you fill all the 19 to first energy level? How many maximum? 2. No need to write 2E. Electron kila you don't need to write, just 2. Put a comma. Out of 19, 2 gone. How many remaining? 17. Can you fill all the 17 to L? No. How many maximum? 8. Out of 17, 8 gone. How many remaining? Out of 17, 8 gone. How many remaining? 9. Can you fill all the 9 into M energy level? Aye. Even though it has 18 occupancy, according to the filling order, can you fill all the 9 into M main energy level? How many maximum you can fill? So first you fill the 8. You can't fill all the 9. First you fill the 8. Out of 9, 8 gone. How many remaining? That you can go to the N main energy level. Now you go to N and fill the remaining. That's the electronic configuration. Now can you see all those doubts that you had before now getting clarified? Why that filling order came like that? This is the reason. This is how electrons are filled. Filling order. Okay. Another one. Calcium. Atomic number of calcium 20. Number of protons then? Electron number? Electronic configuration. Din tell and go. 2, 8, 10 gone. How many remaining? Another 10. Can you fill all the 10 in the third energy level? How many maximum? 8 remaining. 2. Those were the first energy level 2 gone. Out of 20, 18 remaining. All the 18 you can't fill to second energy level. 8 gone. Remaining 10. All the 10 you can't fill to third energy level. Why? Even though you can fill 18, according to filling order, only 8 can be filled there. So you fill that 8. 2 remaining, fill it to the fourth energy level. Okay. What about hydrogen? Atomic number 1. Proton number 1. Electron number 1. Electronic configuration also 1. Okay, only 1 electron is there. It's filled like that. Understood that point? Clear about electronic configuration now? We'll first read electronic configuration representing how electrons are filled in respective energy levels from the one nearest to the nucleus of an atom, and outward is called electronic configuration. Write the electronic configuration of following elements. Wait, I make a big work is there for you. Come to this board. In a side, you can write and keep K2, L8, M18, out of that only 8, N32. I want you to write the electronic configuration of all the elements I'm going to write on the board. Hydrogen atomic number 1. Helium. Lithium. Start. Work. You can write. In the space given, you can write. Online, online people, once done, tell me done. Online people done. Second correct. Hydrogen 1, helium 2, lithium 2, 1, 2, 2, 2. You can understand the pattern. 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8. Now, 2, 8, 1, 2, 8, 2, 2, 8, 3, 2, 8, 4, 2, 8, 5, 2, 8, 6, 2, 8, 7, 2, 8, 8. Now, 2, 8, 8, 1, 2, 8, 8, 2. Okay, right. That's it. Electronic configuration over. Any doubts about electronic configuration? All clear? Back row? All clear? Right. Come to this board again. Shh. Modern periodic table. Modern periodic table. Listen value. Shh. Now these elements are there. No? Day by day, scientists started discovering elements. Initially, there were about 60 or 70 elements. Then it become 80, 90, 100. Now 115. More than 115 elements are there now. Now think. Can we learn about each and every element separately? It's really hard to learn. No? Hard to learn, can now. What are the things you need to learn about element? You should know the atomic number of element, mass number, number of proton, number of neutron, number of electron. Their first ionization energy, second ionization energy, third ionization energy, electronegativity. Are they metals? Are they non-metal? Is they oxide acidic? Is they oxide basic? Is they oxide amphoteric? It's just 5%. Lot of things are there which you need to memorize and keep for each and every element. To learn about one element itself, our brain goes off. 115 elements. Is it possible? Not possible. Scientists also felt the same. Initially, now only 115. By the time they discovered about 90 itself, they felt, you make a run bad and I can't memorize these things. We need a proper system to put it into something in which we can get the data from that easily. Usually, if you want to get the data easily, what we do is we put it into a table. Because when you put something into a table, it's way more easier to extract the data from that. Now, for example, see, I will tell something as a sentence. Uh, students coming to your school, not class, to your class, school class, school class, that class. Students coming to your class in the school. Let's just take, I'll give some data, raw data as sentences I'll give and go. Let's take 10 students are coming in van, 5 students are coming in bus, 20 students are coming by walking, another 5 students are coming by running, another 3 students are coming by swimming, 1 student is coming by flying. When I tell it like sentence, is it easy for you to process? Just imagine I write and give you. How many time principal has to read that sentence to understand about each and every student? What hard no lawan. But if I put that data to a table, students coming by van, students coming by bus, students who are walking, number of students who are coming by running, swimming, flying. If we put it into a table, way more easy to quickly get the data out. No? It's way more easy to understand the data. No? Same thing scientists also thought. They thought if we can put all these elements to a table, then we can extract the data from that way more easily. But putting them into a table is not easy. Because when you put them to a table, there should be a certain pattern. There should be a certain change there. Here and there, you can't put the element. A certain pattern should be there. A certain order should be there. In an orderly manner, you need to arrange the element to a table. More a difficult task. Different scientists tried to put them to a table. They failed, they failed, they failed. Finally, there was a good person. Collar, Ilai, Leaf, Mendeleev. His name is Mendeleev. So what did this Mendeleev do? He arranged all these elements to a table. That table is called as modern periodic. I won't tell his periodic table is 100% successful. There are some errors in his table also. But still, it is somewhat successful arrangement. Okay, then you all tell me, modern periodic table was introduced by whom? Mendeleev. Who introduced? Mendeleev. Okay. Actually, by the time he introduced, there were only 90 elements. Later on, new elements were discovered. Still, they are discovering new element. 2017, a new element was discovered. 20, there was a new element. Still, they discover new element. So when they discover new elements, they add it to the table. Now, Mendeleev is not there now to add it to the table. There's a separate organization, IUPAC, International Union for Pure and Applied Chemistry. That union adds new elements into the periodic table. They decide how it should be added. Okay, so like that, still this modern periodic table is being developed. Okay. That full modern periodic table is given in next page. The bigger one. That periodic table not needed for you. What is needed for you is the first 20 element periodic table, the shorter version of it. Not the 115 full element periodic table. First 15 element periodic table only you need to know. Now listen. When Mendeleev is making the modern periodic table, what are the two criteria he used? What are the two principles he used to make that periodic table? One, atomic number. Two, electronic configuration. So he didn't add the element as his wish. He added the element depending on their atomic number and electronic configuration. Very famous exam level question. What are the two criteria that Mendeleev used when adding the element to the periodic table? Atomic number and electronic configuration. Again, what are the two criteria? Atomic number and electronic configuration. So accordingly, when he arranges and finishes, elements that show similar properties record in same intervals. What are that? Elements that showed same properties, similar properties, they record again and again. They came up in a similar order. You'll understand that order later. Okay. Now I'll draw the modern periodic 20 element periodic table introduced by Mendeleev. 20 element periodic table introduced by Mendeleev. Listen, will you? Right. Periodic table. It's a table. Any table you take will have vertical columns. Columns will be there. Any table you take, there will be vertical columns. In 20 element periodic table, there are 8 columns. How many columns are there? 8 columns. 1, 2, 3, 4, 5, 6, 7, 8. 8 columns are there. Any table you take, there will be horizontal rows. In 20 element periodic table, there are 4 horizontal rows. How many horizontal rows are there? 4. Now this is one row. Even though only first and the second cells are there, this is one row. First row, second row, 2 rows, third row, 3 rows, and the fourth row. So how many vertical columns are there? Columns there. 8 columns. How many horizontal rows are there? 4 rows. Again, how many vertical columns? 8 columns. How many rows? 4 rows. How many columns? 8. How many rows? 4 rows. See, first row, second, third. Now we can arrange the element into them. It is arranged according to what two criteria? Atomic number and electronic configuration. See, hydrogen, atomic number 1 comes first. Helium, atomic number 2 comes second. This is atomic number 1. I'll indicate the atomic number. I'll draw it a little bigger, no? guys. Hurry, right. Shh, shh. Hydrogen, there you go, atomic number 1. Helium, there you go, atomic number 2. Shh. Lithium 3. Beryllium 4. Boron 5. Carbon 6. Nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, 20 elements. Okay, arranged according to the atomic number. I'll tell how electronic configuration comes into play there. First, we will read. Take modern periodic table part. As at present, more than 115 elements have been discovered. But now, more than 115, 120 wagi there are. At a periodic table for classifying the elements was first introduced by Dmitry Mendeleev. What Mendeleev? Dmitry Mendeleev, a Russian scientist. Underline or highlight his name. Dmitry Mendeleev. Modern periodic table is based on what are the two criteria? Atomic number and electronic configuration. Underline or highlight it. Atomic number and electronic configuration. The periodic law states that the properties of elements are periodic functions of the atomic number. This means when the elements are arranged in ascending order of the atomic number, elements with similar properties recur at regular interval. Now see, once when the elements are arranged according to the atomic number. Now it's arranged, no? Elements with similar properties recur at regular interval. That means lithium, sodium, potassium. All those three shows similar properties. Beryllium, magnesium, calcium, similar properties. Boron, aluminium, similar properties. Nitrogen, phosphorus, similar properties. Helium, neon, argon, similar properties. So can you see, once when they are arranged, similar properties elements, they recur at regular intervals. That is why this modern periodic table is important. We can't build it in the way we want. See how much Dmitry Mendeleev has thought. Huh? In case if the number of columns are 7, can this happen? If the number of columns are 9, can this happen? So mathematically you need to think. Regular interval for them to recur. Okay. He didn't build for 20 elements, he built for about 90 elements. Then think how much he has to think. Okay. Next page, that big periodic table is given. That one no need. Under the 20 element periodic table. In that box, I want you all to draw this. Nicely draw it. I want some space here. Some numbers will be coming here. I want some space here. Some numbers will be coming there. So just sit in that box and draw. Now think like This whiteboard border is the box. Adjust it to the center and because there will be some numbers here, some numbers there. Hurry. Shh, shh, shh. Right. Shh, shh, shh. Two important points. Shh, 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 shh. Two important points. One, what are groups? What are groups? Listen, shh. What are groups? Vertical columns in the periodic table are called as groups. What are groups? Vertical columns. See, shh. These columns, vertical columns are called as groups. Then you all tell me how many groups are there in 20 element periodic table? 8 groups are there. 8 vertical columns are there. Then 8 groups are. Okay. Each group is assigned a group number. Each group is assigned a group number. This group number should be written in Roman numeral. In what numbers you need to write it? Roman numeral. See, this is group 1, Roman number 1. This is group 2, Roman number 2. Group 3, group 4, 5, 6, 7, and there you go, 8 groups. 8 group is also called as 0th group. Okay, so Roman numbers are used for group numbers. Clear? Can you all mention the group numbers in a different color pen? Use Roman numbers. Huh? Last one mention it as 0th group also. Right, come back to this board. Shh. Next, what are periods? Listen, what are periods? Shh. Horizontal rows. Horizontal rows in the periodic table are called as periods. Horizontal rows. Shh. Horizontal rows are periods. Shh. Did you all tell me how many periods are there? 4. 4 rows are there. 4 periods are there. Each period is given a period number. Period number is assigned in Hindu Arabic numeral. Shh. Period number is assigned in what? Hindu Arabic numeral. Now, some of you are wondering, what is this Hindu Arabic numeral? That's the normal numbers we use, Lamai. We know Roman numbers. We don't know the normal numbers that we use. 1, 2, 3, 4. This is Hindu Arabic numeral. Okay. So, tell me group numbers assigned by what numerals? Roman numeral. Period numbers assigned by Hindu Arabic numeral. How many groups are there? Adi, groups. 8. How many periods are there? Mention it. Hurry, right. Shh. A small concept. Shh. Listen, eh? Shh. Small concept. I'll just randomly take an element. I'll just randomly take an element. We'll take aluminium. Yeah, randomly I'm selecting aluminium. 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 What's the atomic number of aluminium? Tell me. Louder, louder. Atomic number of aluminium 13. Hinang, how many electrons are there? 13. What's the electronic configuration of aluminium? 2, 8. Ade, huh? 2, 8, 3. 2 plus 8, 10. Remaining 3 are there. 2, 8. Lamai. The electrons in the last energy level. This is the electrons in last energy level. No? Electrons in the last energy level is called as valence electron. What is that electron called as? Valence electron. Then you all tell me how many valence electrons are there? Louder. How many valence electrons are there? Valence electron is 3. Second, tell me what's the group number of aluminium? 3. Marcine. Valence electron 3. Group number also 3. Now that I took randomly, no? It might be coincidence. We'll take another one. We'll take another one. You all tell me any other element. Carbon. Hurry. We'll take carbon. Atomic number 6. Carbon atomic number 6. Electronic configuration, tell me. 2. Huh? 2 gone. How many remaining? Ayyo. Lamai. 6. Hurry the. 6 is equal to 2 plus how much? 4. You all know that, no? Then how many more? 2, 4. Tell me, how many electrons are there in the valence shell? Nathang valence electron, how many are there? 4 valence electrons. Check and tell me, what's the group number of carbon? Marcine. Group number also 4. Or we'll take another one. We'll take sulfur. Hurry, sulfur. Sulfur taken. Atomic number 16. Atomic number 16. Electronic configuration 8, 6. Number of electrons in the valence shell 6. Check and tell me the group number. We'll take another one just to confirm. Sodium. Atomic number 11. Electronic configuration 8, 1. Number of electrons in the valence shell 1. Group number. Now can we build a relationship? No. Can you build a relationship? Tell me the relationship. Group number is equal to. Group number is equal to. You all tell me. Group number is equal to number of electrons in the valence shell. Nothing valence number of. Make sense? Group number is equal to number of electrons in valence shell. That's the last energy level. Last energy level, not the full energy level. Last energy level. Number of electrons in last energy level, that's the valence shell, is equal to the group number. Got it? Now turn to the next page of your tube. Group number. Vertical columns in periodic table are groups. Group numbers are assigned in what numeral? Roman numeral. Number of electrons in valence shell is the group number. Underline or highlight it. Example, write these examples. These 4. Just circle the valence shell in dotted line and write the group number. Write that same thing. Yeah. In the dotted line, write it. Write in the same way I have written this part. No need to write this one. It's given. No? Right. Finally, period number. What's the numeral you use? What's the numeral? Hindu Arabic numeral. Right. Here also, I just randomly select the element. I'll just randomly select element. For example, I'll select boron. Boron. What's the atomic number of boron? 5. What's the electronic configuration of boron? 2. Question. How many energy levels there are in boron with electrons? See, here one energy level is there with 2 electrons. Here another one more energy level is there, 3 electrons. Then how many energy levels are there with electrons? 2 energy levels. What's the period number of boron? Louder. Wait. We'll select another one. Randomly. Random magnesium. Hurry. Magnesium. Shh. Atomic number of magnesium. Louder. Electronic configuration. 8, 2. Number of energy levels with electrons. 1, 2, 3. I have marked tally marks. Huh? What I'm marking here is tally marks. Don't think 111 is I'm marking tally marks and going. So 1, 2, 3. What's the period number of magnesium? 3. Wait, another one will take. Potassium again. Potassium. Atomic number. Louder. 19. Electronic configuration. 8, 8, 1. Number of energy levels with electrons. 4. 1, 2, 3, 4. Period number. One more. Hydrogen. Atomic number. Electronic configuration. Number of energy levels with electron. Group period number. Make the relationship and tell me. Period number is equal to Tell me, period number is equal to number of energy levels with electron. Again, tell me, period number is equal to number of energy levels with electron. Got it? Now wait. Shh. I told you before starting this periodic table itself, Dmitry Mendeleev made the periodic table based on two criteria. What are the two criteria? Atomic number and electronic configuration. He filled them according to the atomic number. Group number, period number are assigned according to what? Electronic configuration. Can you see? Here we are using electronic configuration. Here also we are using electronic configuration. That's why we say both those criteria are used to make the periodic. Okay. Turn to next page. There's a small correction to be made. Next page, period number. Horizontal rows in a periodic table are period. It's given as groups. Cut it and make it periods. Period numbers are assigned in Hindu-Arabic numeral. Number of energy levels carrying electron in an atom is period number. Example, quickly write down the example. Lot of work is done. The fundamental of chemistry, about 90% is done. Right. Shh. Question. Shh. Helium. Helium's atomic number. Helium's atomic number. Electronic configuration. Number of electrons in the valence shell. 2. Then group number should be. Adi, number of electrons in the valence shell 2 now. Group number should be what? 2. But what's the group number? What's the group number of helium? It Maraini. In Dmitry Mendeleev, did he make a mistake? This much nicely he made the periodic table. Or did we make a mistake? Helium number of electrons in the valence shell is 2. A group number should be 2. We have gone and written it in 8 You also have written that. Check and see. You also have written that. Marzine. Hari, Enang, shall we remove that and write it in the second group? Mistake should be corrected. No? Shall we remove that and write it? But again, there is a mistake. No? Why? See, helium, according to the periodic law, it should be in the second group. But also periodic law states us elements that show similar properties recur. Helium, neon, argon, all of them are similar in properties. All three are noble gases. All three are inert. All three never make bonds. All three final valence shell number of electrons are fulfilled. All those three show similar properties. But if you take it and put it in here, helium, magnesium, is there any similarity? No. Helium, calcium, any similarity? No. That's why, even though helium should be in second group, it is kept in the 8th group because it shows similar properties to neon and argon. That's why I told you his periodic table is not 100% successful. Still, there are some errors. This is one of that error. Cannot be corrected. You can't correct it. If you take it and put it here, again error will come. So this is an uncorrectable error in determinant periodic table. Wait. තව එකක් homework. Page number 9. A nice table is given for y'all. Write all the 20 elements. No need to write their full name. Symbol is enough. HE, listen. Write their symbol, atomic number, electronic configuration. Group number should be written in what numeral? Roman numeral. Write it in Roman numeral. Period number should be written in what numeral? Hindu Arabic numeral. Complete that table and come back next week. Next week, what time is the class? New students, 10 o'clock to 12:30 is our normal time slot. So next week, I'll meet you all at this time. Those who are not there in the group, send a message to the number in the tute. I will add you all to the group. Okay. Okay then, enough for today. Go home, revise,